HL congruence theorem. The HL here stands for, this is an acronym for hypotenuse leg theorem. So that's what we write over here, HL, hypotenuse leg. Before we go over the HL congruence theorems, let's identify first by the way, these HL congruence theorems can only be used for right triangle. We can tell if the triangle is a right triangle if there is a small square in one of the corners. So that small square tells us that it's 90 degrees. It's a right angle. So what are the parts of a right triangle? First, we have what we call as the legs of the triangle. So this is a leg and this is another leg here. So the legs of the triangle are connected to the small square. So once you see the small square, next to that would be the leg. Across the small square is the hypotenuse. So that's every time. Connected to the small square on the corner are the two legs. Across the small square, which is 90 degrees, is the hypotenuse. So how do we have, or when can we have an HL congruence theorem? So in this picture here, this is an example of an HL. This too can be proven as congruent triangles based on the HL. By the way, there's a tick mark here and there's also another tick marks if it's not clear. And there's like a small square. Okay, now let's identify the hypotenuse here because we say HL. So the two corresponding hypotenuse would be BA. That's the hypotenuse. What is the corresponding hypotenuse on the other triangle? ED. Okay, so BE is congruent to ED and that is the hypotenuse. Let's identify the corresponding legs that are congruent. So we have CB is congruent to FE. So we can go ahead and say that this two triangles are congruent to each other by HL. Now let's go over some examples. So our choices here is HL or not HL. So we have a label here, AB. What is this part? Hypotenuse or leg, the AB? This is a leg. And this is also a leg here, EF. What about AC? That's a tick mark. What is this? Leg or hypotenuse? Hypotenuse. And this one is also hypotenuse. Do we have a HL now? Yeah, hypotenuse leg. Hypotenuse leg. And it's a right triangle. So this is HL. Let's match up the parts. So triangle ABC, ABC. So I start with A, I cross one tick mark and then go to the small square. So how would I set up on the other side? I start with F, I go to E, then I go to D. So that is our A to B is crossing one tick marks and our F to E is crossing one tick marks. Our B has a small square, our E has a small square. And so this is the correct congruent statement. Let's have another example here. I'll give you a minute to figure this out. Okay, so let's go over this. Is this HL or not HL? What is our KJ? That is a what? A leg or hypotenuse? That's a leg. Okay, good. So this is a leg. And this is another leg here. Where is the hypotenuse here? In the middle. So this is the hypotenuse. So can we say that this is HL? Yes. So this is an example of HL. Our leg have been labeled. The hypotenuse is shared by both of them. So that is HL. So let's find the congruent statement. JML. So from J, I cross one tick marks, I go to M with a small square. So I start with J again. I go to one tick marks, I go to K, and then L. So that is JKL. Who got the same answer as this? Just raise your hand. Good. Let's have another example. So it's pretty straightforward, yeah? Okay, so let's go over this example. So is this HL or not HL? Not HL. Why is it not HL? There's no label for the hypotenuse. So this one is leg. This one is also a leg. There's no LL. Okay? But it's HL. So this is not HL. However, this is another example of a what? These two are still congruent to each other. This is angle side angle or side angle side. It's gonna be side angle side. So that's SAS. So because we have a side, an angle, and a side. So if we have PTQ, so how should we set it up? That would be STR. Okay? That is how we show that the two triangles are congruent based on HL congruence theorems.